So welcome to the 2022 CPP End of Season Volunteer Celebration. Let's start with introductions. I think that most of you know us, but just in case you don't, we'll go ahead and do introductions. I'm Megan Mueller. I'm a conservation biologist with Rocky Mountain Wild and a member of Rocky Mountain Wild's leadership team. And I co-direct the Pika project with Alex. Alex, you want to introduce yourself?
Yes. So, hi, everyone. I'm Alex Wells. I'm Denver Zoo's Community Conservation Coordinator. I'm the one who sends most of the pestering emails to all of you. And as Community Conservation Coordinator at Denver Zoo, I have my hands in a lot of our local community science work. And first and foremost, in my heart and on my timesheet is the Colorado Pika Project, which I co-direct with Megan. And then Julie and Hillary, do you want to unmute yourself and turn your video on and briefly introduce yourselves as well?
Yeah, I don't know if you can see me. It's really dark where I am, so hopefully it works. Hi, everybody. I'm Julie Kreski. I'm the Colorado Conservation Specialist at the Denver Zoo. So I work with Alex and Megan on this project and on some of the other conservation projects that the Denver Zoo does here in Colorado, like our boreal toad work, our work on Mount Evans, and with Rocky Mountain Wild up on East Vale Pass.
Hi, I'm Hillary Woodworth, a carnivore keeper at Denver Zoo, but I also spend 10% of my week working as a project assistant for the Pika project. So I take out other zoo staff members to Pika surveys, and I'm learning how to do a lot of paperwork and training.
All right. So our plan for this evening is to spend a little time talking about our highlights from this year and what you guys all accomplished together this year. And that is going to be fun because it's pretty amazing. We had a record year this year. And then we're going to bring in a guest speaker named Peter Billman, who is getting his PhD at the University of Connecticut. And he's going to do an interesting presentation about how mountain mammals exhibit opposing responses to recent warming. And that's about pikas and marmots and wood rats. And then we're going to talk briefly about the Colorado Carbon Offset Partnership. And then we're going to talk a little bit about the plan for 2023 and do some shout outs to volunteers who really went above and beyond this year. And then we'll have some time for questions and conversation. We had one guest speaker who had to cancel, and so I think we're going to end a little earlier than scheduled probably, or just have more time for you guys to ask questions tonight. So we've got this Zoom until 8, and we can just kind of end when you guys are ready and have all your questions answered. I just want to note that the Colorado Pika Project takes place on the ancestral and traditional lands of the Arapaho, Cheyenne, Ute, and 7 Council Fires people. And it was also the site of trade, hunting, gathering, and healing of other indigenous peoples, including the Comanche, Apache, and Shoshone. So let's start with just some fun stats from the year. This was really a record year for us, so I want to thank you all for making it such a great year. We had 139 new volunteers, 127 returning volunteers, and we had 240 volunteers who conducted surveys, which is so amazing. And we just can't thank you all enough for getting out there and doing that many surveys. When I did the math for this slide, I had to keep doing it over. I thought I was getting something wrong because you guys contributed 2,287 hours and you hiked 2,026 miles, which is just incredible. And I know this picture has sort of the idyllic version of a Colorado Pika Project hike, but I'm sure that a number of you did hikes that didn't look quite as idyllic as this, or just had, really challenging terrain or other things that you had to overcome to successfully get to the site. So we really appreciate all the time and effort that you all put in. If you were around last year, you'll remember that we did a Survey 123 dashboard. This is kind of an interactive map where you can explore our results from the project. And we're not going to go through that too much tonight, but we are going to send a link out to you guys so that you can all explore the dashboard. You can look at the map, which shows sites where pikas are present, sites where there's never been any sign of pika, and sites where there is only old pika sign. And the kind of take-home message this year from looking at that dashboard and comparing it to previous years is that we have kind of a growing number of sites where we only find old pika sign. And that's partly because we're adding new sites. And so we're just finding more of those. And that's interesting because it could mean that pikas were there in the past and they've been lost from those sites. Or it could mean that those are sites that just kind of periodically get colonized, but pikas aren't consistently present. And so next year, we're really going to be digging into that a little bit more and doing some surveys with staff and other experts and potentially a larger number of volunteers at those sites to figure out whether there are sites where pikas used to be present and just aren't present any longer. And to really confirm that we've lost pikas from those sites, we need to survey all the talus in the surrounding area. And so that's something that we're kind of figuring out exactly how to do and something we'll be talking with you about next year. So watch your email and you'll get a link to this dashboard and you can check it out and look at your sites that you went to and see what other people found at those sites and things like that. So this year we had a record number of sites surveyed. It's pretty exciting. It's the first year that we've had all of the sites that we wanted to get surveyed actually get surveyed. And then we also had a lot more repeat surveys this year, which is really important for us. That is really exciting. There were also to go to really hard sites that no one had signed up for, and we got a pretty amazing response to that. So we really appreciate that. We also completed the ground truthing of all of the sites that we wanted to set up in each study area. So that's something that staff's been doing for several years. And now we have all of those sites ground truths to make sure that they're safe for volunteers to access. We have them marked with cairns. We placed temperature data loggers at all the sites where we wanted to have those. And then we've got site descriptions for all those sites. So that was a heavy lift on the staff side of things. And we're excited to have that done because it frees up our time to start focusing on other things like working on starting to analyze you guys' data. And then we also released the Pika Patrol app this year, which is something I think those of you who have been around for a while know that we've been working on for a long time and really for a lot longer than we wanted to be working on it. So that was really exciting. And you can use that app on your smartphone to go out and make opportunistic pika observations anywhere in Colorado and really anywhere across the West. If you happen to be on vacation in the Tetons or Yellowstone or Montana and you want to record pika observations, you can do that too. So we're hoping folks will get out and use that. We released it at the end of the year this year, even though it was very close to the end of the field season, mainly because we wanted some of you to get out and test it out and give us feedback on it so that we can work out any kinks before we have a much larger number of people using it to make pika observations next summer. So if you've used it and you've noticed things that don't work well, we hope you'll let us know and then we can work on fixing that stuff. So the other thing that we're excited about this year is that the Denver Zoo has a new data analyst who is going to be helping us take the humongous pile of data that we have in our database and start really doing some analysis and figuring out answers to our research questions. That's something that we've been wanting to do for a long time, and it's been hard to find the time to manage the project and also do the data analysis that's needed. So we're excited to have some extra capacity on that at the zoo. And Kate did a little bit of exploratory analysis this year just to kind of get familiar with the data. And we thought we would share a little bit of that with you guys tonight. So this slide that you're looking at here, the graph shows the proportion of sites with pica on the y-axis. And so 1.0 means picas are present and 0 means picas are absent. And it's basically the bars you're seeing are the proportion of sites that are occupied by pica in the Front Range and Rocky Mountain National Park and the White River National Forest. And then the x-axis is the year. So what you're seeing here is that the proportion of sites occupied by pica is pretty consistent across years, across all of our study areas. So we're not seeing a big decline in occupancy at any of the study areas. In 2017 in Rocky Mountain National Park, it looks like there are a lot less picas, but I think that's actually just an artifact of kind of a low number of surveys that year, because that was the first year we started doing research in the park. So that's good news, you know, that we aren't seeing a big decline in occupancy yet. And this is kind of raw data. It doesn't take into account detection probabilities. So we're going to be doing a more robust analysis with this data, and we'll report the results to you guys. And then we also kind of did a little bit of exploration of what variables influence whether or not pica are present at our sites. And these are the variables that sort of stood out as being significant in Rocky Mountain National Park. So again, on the y-axis, you can see the proportion of sites with pica. And then on the x-axis, you can see different variables. So elevation, low, middle, and high, talus depth, and marmot sign. You can see that there is definitely a relationship between whether or not picas are present and elevation. And that's something that we sort of expect because elevation is really closely related to a lot of different climate variables. You know, it's warmer at low elevations, there's less snow at low elevations, those kinds of things. And so you can see that a lot less sites have picas at lower elevations, and then sites tend to be occupied at higher elevations. Talus depth also mattered in Rocky Mountain National Park. So picas are more likely to be present at sites that have deeper talus, which is another thing that we expect. We think the microclimates under that deeper talus may be beneficial for picas, helping them kind of stay cool in summer and warm in winter. And then there's a tiny bit of a relationship between picas and marmots. You tend to see slightly higher pica occupancy at sites that have marmots, but it's not a lot higher. And then this is a similar graph for White River National Forest. You can see that there is again a relationship between pica occupancy and elevation in the White River National Forest. Picas are more likely to be present at higher elevations and less likely to be present at lower elevations. Something that's kind of interesting in the White River National Forest is that there wasn't as much of a relationship between talus depth and pica presence in the White River. And we're not totally sure why that is. One thing that I think could be happening there is that we have a lot of sites up in the flat tops, and in part of the flat tops that was burned a long time ago and has pretty shallow talus and really amazing vegetation. And then also picas are kind of using the down trees almost like talus. And so it seems like they're using much shallower talus there, and that might be kind of influencing what we're seeing in this graph. But we haven't really looked into that in a lot of detail, and it will be something that'll be kind of interesting to explore. And then again, there was a little bit of a relationship between marmots being present and picas being present. So we're going to be looking into all of that data quite a bit more, and it's going to be a big priority for us this winter. And so we're hoping to share some more results with you over the next year and a half or so. And then I wanted to stop there on sharing highlights from the season and then to share this really fun pika video just for fun. So that video was done by Kristi Odom and her team, and she's actually doing a documentary about pikas here in the Rocky Mountains and the Colorado Pika Project. She's really interested in interviewing volunteers, so if you would be interested in being interviewed, let us know. And I think now we're going to go ahead and have our guest speaker, Peter Billman, give his talk. So Peter, do you want to unmute and unmute yourself and turn on your video?
Sweet. All right, can you see that?
Hi, Peter.
How's it going?
Good. Welcome.
Good. Thanks for having me.
Yeah. So do you want to just introduce yourself to folks and then go ahead and share your screen? And
Yeah, totally. Yeah. So my name is Peter. I've been working on pika since about 2015 now. I used to live back in Montana, but I'm currently at the University of Connecticut working on my PhD. And so it's hard to leave the pika world, even though I live in the East Coast now. So I'm out there every summer still researching the pikas. This past summer was in Colorado primarily. And so I'm going to give a talk, a little bit of some of my dissertation work about what we found this past summer. So I can share my screen here. So today I'm going to be talking a little bit about what we've been finding in terms of pikas, wood rats, and marmots, and looking at how these species are responding differently to climate change here in the Southern Rockies. So starting off, we really have this strong emphasis that we really want to understand what factors influence where species can live. There's no animal or plant that lives everywhere on the earth. There's always some sort of factor that's going to limit where they can live, whether that be food, maybe it's sunlight, maybe it's snowpack. And so understanding what factors those actually are is critical for trying to understand where species are going to move to in the future. So one recent meta-analysis found that there's this theory that goes back to Darwin on whether or not species range limits where they can live elevationally, for example, is driven by biotic factors or abiotic factors. So biotic being whether essentially plants, food, things like that, or competition. So this theory suggests, and this paper recently found, that warm or lower limits, for example, those are more determined by biotic factors. And so they found across all these different studies in the world that lower limits, so for pikas and marmots, for example, they have a lower limit in Colorado. Those would be driven by competition, maybe food, some other biotic factor, whereas species upper limits are going to be more determined by abiotic factors. So that's going to be your climate factors typically. It's going to be snowpack, it's going to be cold temperatures, things like that. There's been evidence of oxygen being a limiting factor for some species. And so this study really found that lower limits determined by biotic cooler upper limits driven by abiotic factors. And so, like I said, today in the talk, I'm going to be talking about these 3 montane species that most of you folks are probably already aware of. Of course, we have pikas, everyone's favorite. And then we have the yellow-bellied marmots, and then the bushy-tailed wood rats. All 3 of these species occupy the mountains in Colorado. Whether or not you've seen wood rats and marmots is going to depend on where you're at elevationally. But I'm assuming most folks have seen at least pikas and marmots, likely not wood rats since they're nocturnal. And so the 2 motivating questions for this research are, have pikas retracted upslope in the Southern Rocky Mountains, being Colorado, New Mexico, and Eastern Utah? And so we do suspect that there has been some level of retraction upslope. However, we assume that that distance that they've moved upslope, their lower elevational limit has moved upslope. We assume that that's probably comparable to what I found during my master's research back in Montana and Idaho. And so the assumption is that it's probably relatively close to the same. And then question number 2 is, what determines species range limits? For these 3 species in particular, is it going to be those biotic factors or is it going to be those abiotic factors? And so the hypotheses is that pikas and marmots are going to be limited in their lower elevational limits due to climate, whether that be temperature or precipitation. And then we assume that wood rats are actually going to be limited in their upper elevational limits because they typically don't occupy the peaks in Colorado. They do in a couple areas, but typically not. And so we assume that they can't live at the tops because some sort of other interactions with other species, whether that be pikas or marmots kicking them out, we're not entirely sure. And so those are the 2 questions we have. This figure on the right just kind of shows what those upper and lower elevational range limits are like. So alpine species typically only have a lower range limit. Think pikas, marmots, wolverines, things like that. They have a lower limit, so they don't occupy all the way down to the valleys. And then we have other lowland species which have an upper elevational limit only. There's a lot of butterflies, for example, certain types of mice. They don't live all the way up to the peaks. And so the three species that we'll be talking about again, pikas, yellow-bellied marmots, and bushy-tailed wood rats, they have very heavily overlapping ranges, you can see here. The bushy-tailed wood rat is the one that moves, or that expands, I guess, the furthest north up into the tip of Alaska, actually, whereas the pika is a bit more restricted to the mountain ranges, and marmots can live in some lower elevational areas, but typically they are restricted to mountain ranges. And so this slide here just to show that there is really heavy overlap in where these 3 species can live. They seem to occupy some similar niche related to mountains in the Western US and Canada. And so these are really interesting species because we know that we can see pikas, we know that we can see marmots. We can also tell that they're there based on indirect evidences, such as their fecal pellets. And so we have the pika fecal pellets, which of course are going to be perfectly spherical. Most of us have probably seen those. And then we have the marmot fecal pellets, which are going to be much larger, much stinkier when they're fresh. They're really, you can tell when they're fresh because they're very green, similar to pika scat. And then we have the wood rat, where we can see their indirect evidence is based on their fecal pellets, which are going to be much more oblong. And most people, I'm guessing, have probably come across at least one fecal pellet during your guys' surveys, unless you're at the highest of high sites. But wood rats are actually nocturnal, so you'll never really see them in the day. It's pretty rare. I've personally never seen them, but we can see that they're there based on their current evidences. We can find those fecal pellets, we can find fresh urine stains, we can find their nests, which is that bottom photo there. They build these really big nests. They actually put bones and things like that in there as well. And so you can tell these nests are active based on how fresh the vegetation is in there. And then on the bottom left, we have pikas, which of course have hay piles. And then in the middle, we have a den of a marmot, which has fresh vegetation bedded down in the bottom of that little cave that they live in. And so all 3 of these species are really interesting because we can tell that they're currently there based on certain types of evidence. And then we can tell where they are not, they're no longer there based on old evidences. And all these species are not 100% detectable. Sometimes marmots are going to be hiding when we go survey. And so we might not see them, but we'll see their scat. And so this past summer, I'll be focusing just on the southwestern portion of Colorado. This is primarily the San Juans, and a little bit into New Mexico and the Sangre de Cristos, and then the La Salles over in Utah. But primarily this is the San Juans of southwestern Colorado here. And then we have Durango right in this area right here, just for reference. I did some surveys in the Front Range, but I don't have enough to actually have robust results up there yet. Getting that a little bit later, but in this figure here, these sites, each of these dots represents a different talus patch. What we did was we did these elevational transects. We surveyed elevational watersheds, I guess. Okay, so we surveyed watersheds from low to high elevation. We found talus patches with satellite imagery, and we tried to find the lowest ones in that watershed and then the highest ones in that watershed. And we surveyed a bunch of them on the way up. So you hike up the mountain, survey, survey, survey. And so these green dots here represent where we found pikas currently. The orange dots represent where we found evidence that pikas used to be there, but pikas are no longer there. And then red represents where we found no evidence whatsoever suggesting that pikas have not been there in a long time. And so you can see there's actually one mountain range where there's actually no evidence that pikas have ever been there. This area right here is going to be Great Sand Dunes National Park. And so it's just east of there a little bit. But that's a mountain range that should have pikas. The habitat was very suitable. There just wasn't pikas. They may have never made it there. And then this figure on the right-hand side is just a more zoomed in version of that. And so that's going to show what it looks like going from no evidence at really, really low elevations where it's really hot and dry. And then you find in the middle elevations, you find that pikas used to be there, but no longer are there. And then the highest elevation sites are going to be pretty much all occupied by pikas. Use the arrow, I guess. So as I said, we looked at these different gradients, these elevational gradients, and we surveyed all over the place, trying to get some of these warmer, drier sites. So this bottom right photo is one of the talus patches in Utah, very hot, very dry. And this one in the upper left is going to be in Colorado, near Lake City somewhat, a really hot, dry site as well. And then we have some of these alpine sites that are a lot cooler and wetter, a lot more snowpack, a lot more precipitation. This is actually the La Salle's in Utah as well, near Moab in the upper right corner. And the bottom left is going to be, I believe it's Ice Lake near Silverton down there. So we have a wide array of sites from really hot, really dry to really cold and really wet. And I believe there was 157 sites in total this past summer. So getting into some of the preliminary results, what we found with pikas here, this 0 represents sites that were unoccupied and the 1 represents sites that were occupied. And so to no surprise, we find that these higher elevation sites are gonna almost always have pikas. There's no surprise, we know that pikas are an alpine or montane species, typically at higher elevations. So to no surprise, we found them up high. And then of course, we found that they used to be at sites at mid to low elevations, but no longer occupy those warmer, drier areas down low. And so that was pretty much exactly what we thought. It's what we found elsewhere. It's what we found in New Mexico from a different study. It's what we're finding in Montana and Idaho. So yeah, there's something going on with elevation here, likely a climate signal. And then with yellow belly marmots, we actually found the same thing. These look almost identical between pikas and marmots. We don't find marmots at these really low, really hot, dry sites. But we do find them almost everywhere up high. This is especially the case in San Juans. Marmots, for some reason, there are just absolutely everywhere. There's very few places where you don't find marmots. And then lastly, we have the bushy-tailed wood rats. Notice how this figure now is basically the exact opposite. We see that wood rats are not occupying these high elevations, but they are occupying almost all of the lower elevation sites. So there's something going on. Do wood rats just really like the heat and the dryness, or are they avoiding these higher elevations where pikas and marmots are because pikas and marmots are there and potentially excluding them? So getting into what we did. So this is structural equation modeling. It's not exciting. It's just a complicated way to say you did some statistics. And so what we found with this is that pikas seem to be affected by these 3 climate metrics most strongly. That's your maximum summer temperature. So the hotter your site gets, the less likely you're going to have pikas. Winter precipitation, that's a positive effect. So the more snow you have, the more likely a pika is going to be occupying that site. Exactly what we found elsewhere. And then this is the interesting one, which we don't really understand. More precipitation was actually bad for pika occupancy. No idea what's going on with that. I don't even have a guess of what's going on with that. There may be higher precipitation at low elevation sites, just really not sure. And so when we do more sampling next summer, we may lose that summer precipitation negative signal. However, to our surprise, we found that talus patch size, and so the overall size of that patch, didn't have an effect on whether or not pikas were there. Pretty much every other study that we've had has suggested that the number of home ranges, the number of pikas that could occupy a site, how large that talus is a pretty good predictor. However, we found that it has no predictive influence here. And then the presence of marmots, there was no effect, positive or negative, of marmots on pikas. They occupied similar sites, like Megan had just said. A lot of times where you find pikas, you're going to find marmots and vice versa. And so when it came to marmots, the only factor that actually mattered for determining where marmots are living is going to be your maximum summer temperature. So really hot sites have a negative effect on marmots. However, again, we have this little dash, which it just means it's unimportant. And that's pikas. Pikas have no effect on marmots and vice versa. So these 2 species can seem to coexist with one another, not have any issues with one another, and live their lives separately. And then we have our bushy-tailed wood rats. Just a note in that bushy-tailed wood rats do occupy really high elevations, more northern in their range, and in the absence of pikas. And so wood rats can live in really cold, high alpine areas, but we found that the #1 predictor of wood rats and where they live is whether or not pikas were there. So if pikas are present, we're not going to find wood rats at that site. But if pikas are extinct from that site, or pikas were never at that site, we're going to find wood rats there, most likely. And so it's quite an interesting finding. It suggests that there's something going on between these species and between climate. Surprisingly, wood rats do not appear to be restricted by climate. They're much less sensitive than pikas and marmots are. And so getting into some of the lower elevational retraction stuff here, what we found was that across all these different watersheds, on average, these watersheds, pikas had shown an upslope retraction of their lower elevational limit. And so they're still occupying the peaks, but they're just moving their lower elevation upwards. And so on average, we found that was about 1,100 feet, which is far higher than we expected. All the watersheds retracted upslope or showed retraction, except for one, and that was the Silverton watershed. And that's because that lowest site in Silverton was still just above 9,000 feet. And so it may just not be hot enough yet for pikas in that area. But if we exclude that watershed in our averaging, we see that retraction on average is about 1,200 feet. And so this is actually kind of a surprising finding, given that this is basically double what we found in the Northern Rockies. We assumed that pikas were actually be doing a little bit better in the Southern Rockies, just given that Colorado is so wet and so cold in certain areas. But we found that retraction was, of course, double what we found in Montana and Idaho. This is not great news necessarily. The sky isn't falling. There is a much larger elevational gradient going on in Colorado of talus. But in general, we found the retraction was about double. So this is what that looks like in each of these different watersheds. So these gray areas represent where pikas used to be. And then the green areas represent the elevations that pikas are currently at in any given watershed. And so this is the Greenhorn Mountains. Remember, this is that one mountain range east of Great Sand Dunes that did not have any pikas whatsoever. Funny enough, in that mountain range, because there wasn't pikas, we found wood rats at the highest elevations. The wood rats are occupying the peak in the absence of pikas. Same thing with marmots, they were up there as well. And so there doesn't seem to be a negative effect of marmots on wood rats. It's just pikas on wood rats. And so again, across all these different watersheds, we do see quite a bit of retraction going on. These gray bars, some of them have more, some of them have less. This one that had the most retraction was the one in Utah, the hottest watershed, of course, that we had surveyed this past summer. And so overall, we do see about 1,100 feet on average retraction going on so far, and that's expected to continue given that this is driven by this recent warming going on in the region. And so just to revisit this one slide, what we found was that pikas and marmots theory suggests that their lower limits should be driven by biotic factors such as competition. However, we found the exact opposite. We found that pikas and marmots are both limited by climate, primarily temperature, as opposed to somewhat sort of biotic interaction with other species. And then again, theory would suggest that wood rats' upper elevational limits are going to be limited by some sort of abiotic factor, so climate. However, what we're seeing is that in the absence of pikas, wood rats can occupy the highest elevations, but when pikas are there, these wood rats are limited and kicked out basically to the lower elevation, suggesting that wood rats are actually limited by other species as opposed to climate. So what we're finding is the exact opposite of what theory suggests. And so in the end, we have climate change winners and losers, species that are going to benefit from climate change and species that are going to lose from climate change. And so the two losers are going to be the pikas and the marmots. They're species that are adapted for the cold, they like the snow, things like that, that are going to be disappearing with climate change. And then we have some species that are going to be climate change winners. These are species that can handle a bit more heat. And as these other species, pikas and marmots, go extinct, wood rats will be able to move in. They'll be able to move upslope, occupy more sites in the future. And so upcoming fieldwork, this upcoming summer now, I have to get back to Colorado, survey more of the Front Range, survey more of the Sawatch Range, the Aspen area, things like that, the Medicine Bow Range in Wyoming, just to see if these patterns are holding up across space, which we suspect they do. We do plan to survey some wood rat only mountain ranges, so no pikas, no marmots. And so we're going to go to southeastern Utah for some of those to see where wood rats are in the absence of both species. We also need to look at the importance of talus depth. Megan had already brought up that deeper talus is oftentimes good for pikas because it has more of a refugial characteristics. It's typically colder down there. So we haven't looked at that quite yet. So we plan to look at that here in the future. And then we're going to create some maps of the species distributions. And so looking at where pikas are statewide, marmots are, and then wood rats are, and compare that under different future climate scenarios to see where these species will be moving to. Again, we of course expect those two species to be moving upslope, so their ranges are likely to be a lot smaller in the future, whereas wood rats are going to gain a lot of elevation moving forward. And so then we want to compare all these results to see what we found in the Northern Rockies from my master's research a couple of years ago. That's me, Montana, and Idaho. And so with that said, thank you very much to all of our funders. We've had a lot of people that have provided a lot of logistical support as well. And so I'm happy to take anybody's questions if anybody has any. But yeah, that's what I have for you guys tonight.
Thank you, Peter. That was really interesting. Maybe do you want to unshare your screen so we can see people?
Yep.
And see if they have questions.
There we go.
Great. So folks, if you have questions for Peter or for Alex and I, it's a good time to do that. And you can either drop that question in the chat or feel free to unmute yourself and turn on your camera and ask a question. So Peter, I have one question. It's a question that came up in the in-person celebration, and I thought it would be good to ask just so people can understand what it means when pikas are retracting. So when they're retracting, am I correct that they're not moving upslope? They're not migrating upslope. That means populations at lower elevations are being lost.
Exactly. Yeah. The way we describe it, we say that they're retracting upslope, and that's a great point, is that they're not retracting upslope and that birds can move upslope. Insects can move upslope to avoid those warmer temperatures. Pikas are philopatric, just meaning that, of course, once they occupy their little territory, they're going to stay there for the rest of their life. And so pikas don't have the ability like other animals do to move once they're full grown. They just do not leave their patch for some reason. And so, like you said, they are just dying out of these lower elevations. They're not all moving upslope in unison, which would be much more beneficial because you retain that genetic diversity that we have. However, we're just simply losing these low to mid elevation populations. And so, yeah, they're not really retracting upslope. They're mainly just dying at lower elevations. So there's not an easy way to say that, unfortunately. But that's a great distinction, though.
I have another question.
Yeah.
Do you have any plans to resurvey any of these sites with the thought that like maybe you're in a year where like pikas often recolonize those spots, but for whatever reason, this was a sink year for it, and a lot of more sites were unoccupied?
Yeah, so that's a really good question, because of course, while I would absolutely love to, spatially covering this much ground is really challenging. And so if people want to go resurvey some sites for us, we'd absolutely love it to see what you guys find. With that said, we may resurvey some of them, especially certain watersheds that seem like they should have pikas lower down, to see, like you said, if there was a bad year. This was quite a dry, warmer year in the southwestern part of the state. There was a drought going on, so it's basically snow-free in early June, whereas the Front Range held on to snow until about July. And so it was snow-free much earlier than it should have been. However, all the surveys were conducted in June and July, so early on before the really, really hot temperatures. But we did, with my master's research, we resurveyed 8 different watersheds 2 years after the initial surveys, and we found that the amount of retraction, or where pikas are, their lower elevational limit, actually didn't change over the 2 years in all 8 of those watersheds. And so there's surprising amount of consistency going on. We found a very different story though going on in New Mexico. We have some random sites that have been surveyed year after year, and pikas are kind of just fluctuating all around. However, they're not ever expanding really, really low, which is a little bit surprising. We'd think that in really, really good years that are really cold, they'd be able to expand a lot farther down slope, but they're only able to get basically a couple hundred meters down, if that, at most, never more than say 500 feet lower than they occupied before. And so, yeah, there is this question about interannual variability going on. Yeah, if folks would like to resurvey a couple sites, I'm happy to share sites with people. Those are certainly not private. And so if anybody's in the San Juans and wants to see pikas and share some information with us, we'd love it. But yeah, so I see a question just popped up. Do we have any idea how quickly this retraction is happening? Can we see a difference in just a year, or is it over many years? Yeah, that's another great question, in that we don't have the data yet to tell. It's certainly not happening within just a year. We can have die-offs at lower elevations within a year. That's basically what happened with Zion. They had a couple bad years in a row, and all the pikas kind of just got annihilated by that. However, retractions, we don't have a way to date these, unfortunately, without historical data. So we don't know how long these retractions have been going on for. Likely within the past 10, 20, 30 years, we really started to see increases in temperature across the globe around the 80s. And of course, it's getting worse and worse every year. And so retractions we found in the Great Basin, or not I, but my old advisor has found in the Great Basin that retractions are actually speeding up with climate change. And so as temperatures are getting warmer, they're moving upslope faster and faster and faster. However, for these Colorado data, we just don't know quite yet, unfortunately, how fast that retraction is occurring. But resurveys in future years, say in 5 years from now, 10 years from now, will really be able to tell us that rate at which they're moving up, or I guess dying out at the lower elevations. And I see another question: what is the highest number of pika sites did you survey in a day? I want to say 14. During my master's work, we actually got 24 on a day, and that was covering like 28 miles. And among two of us. And so it's really, really brutal stuff, but it's fun. We all do it because we enjoy seeing pikas and things like that. But this summer, I think the longest day was only 20 miles. And so it wasn't as much as the master's work, but yeah, it's tricky because you're balancing catching every pika, or not catching, but seeing every pika, documenting them all, and balancing that efficiency of getting as many sites as you can.
Yeah, and just to be clear how kind of impressive Peter's fieldwork is, his sites are like all of the talus patches that go up the entire transect. So, you know, he's surveying much bigger sites than we are.
Yeah, and some of them conveniently have roads in those watersheds, and so those always make it a lot easier so you can drive between patches. There's no effective roads. Pikas are right next to the roads. That's always a question we get. They don't seem to be negatively affected by being next to a road versus away from it. And so, yeah, I don't have temperature sensors out, and so I will let Megan and Alex answer the question regarding temperature loggers.
Yeah, so Lisa, we put temperature loggers, I think, at 96 sites across the White River and Rocky Mountain National Park this year. And the idea behind those is that, you know, the temperature that pikas experience under talus is kind of decoupled from the temperature in the air. And so one thing that data is useful for is sort of correlating temperatures under the talus to the air temperature, and then doing climate predictions with that relationship a little better understood. And then it also just tells us, you know, gives us numbers on the temperature pika are experiencing under the talus that we can, you know, put into our models. So we're pretty excited about that. And Irie Peralta, Chris's graduate student, is going to be using some of that data along with data that she's collecting with temperature data loggers and some more expensive, complicated sensors that she puts up above the talus that kind of better relate the temperature above the talus with the temperature that the data loggers are measuring.
Yeah, something interesting with that is we have some sensors across New Mexico right now at sites where pikas currently are and where pikas previously were. And of course, these deeper talus patches are going to have a lot more physical characteristics of staying a lot colder than the ambient temperature at the surface of the talus. However, we're finding that the macro scale, or the ambient temperature climate, is actually more predictive than the in-talus temperature, which doesn't really make sense. Theoretically, that in temperature, or the in-talus temperatures, should be more predictive of where pikas can live, because that's the temperatures that pikas are experiencing. They can just go back into the cold and get away from the heat. However, what we're finding in New Mexico is that actually the macro scale temperature from this climate modeling that we have is more predictive of where pikas are. We're not entirely sure why that is. However, one really important thing with your temperature loggers that you guys have installed out is looking at if you have these really cold drops in the middle of winter, suggesting that the snowpack is broken. And we're finding that warm winters are actually bad for pikas, and that's likely because it creates gaps in the snow where that cold air can really sink into the talus and freeze them. And so ideally we want a high snowpack, and those temperature sensors can see those fluctuations going on in the winter. And we do see a lot of fluctuations going on at the hotter, lower dry sites that have less stable snowpack. And so it's a very interesting thing. It's very strong patterning in that if you have gaps, pikas are typically not there. But yeah, no, I'm not working with them for my PhD work. They take too long to put out, and they're expensive. Okay, so I see Leah's questions regarding other places in the country. Pikas are being studied in every single state that they occupy. So that's going to be every state in the West except for Arizona. It's the only state pikas never made it to for some reason. However, we do have researchers everywhere, whether that be at the state level, the federal level with the USGS is really interested in them, and the Forest Service. BLM even surveys them in Idaho in certain areas. And then we try to cover as much ground as we can. I'm doing Colorado, New Mexico, Utah, and Southern Wyoming. But other folks, there's entire folks at universities dedicated all of Utah, for example. I know Chris Ray covers a lot of Colorado. And so each state actually has multiple people typically working with pikas in it. That goes also for British Columbia and Alberta, where pikas are up there. There's a lot of interest in pikas up there because they can live down to sea level. They live right down to the ocean in certain areas, because it's of course a lot colder and wetter. But yeah, to answer your question, pikas are being studied in every state that they're in. There are pikas, there's like at least 28 other species of pikas in the world over in Asia. And so there's a lot of folks studying those ones as well. There's, for example, 2 different pikas that live on Mount Everest. And so there's lots of different pikas in Asia that folks are trying to study. The American pika being the cutest, of course, but and not all of them occupy talus. A lot of the ones in Asia live in grasslands and things like that. They'll live in like rock fences on people's pastures. They're pretty interesting because they're not all talus dwellers. A lot of them are just meadow dwellers. They're kind of like prairie dogs over there. And so, yeah, there's a lot of work going on across the world on these little guys.
Yeah, and across the West, I think one thing that's interesting is people are finding that pikas may respond to climate change differently, even in different mountain ranges. So having researchers kind of looking at these questions in all of the different mountain ranges, I think is going to end up being really important for getting a handle on how pikas are going to respond.
Yeah, absolutely. Yeah. For example, like what we found in the Northern Rockies is that more precipitation is better for pikas, but then we're finding in the Southern Rockies that more precipitation in the summer is bad. Looking at those differences of why pikas are responding to the same climate metrics differently across their range is really critical. Like Megan just said, it's showing us a lot of interesting patterns. And that's going to help us model more accurately where pikas will move to in the future. So if they ever get reconsidered for listing, for example, as endangered, we'll be able to create more effective maps that really show what they're limited by across their range there.
Well, if nobody has additional questions, we'll go ahead and let Peter go, and then we'll move on to a couple other things. Thank you so much for Peter for coming and for your research in Colorado. It's really interesting.
Yeah, absolutely. And if anybody has any questions, feel free to reach out to Megan for my email address. I'm always happy to chat more about pikas and marmots and things like that with folks. So yeah, enjoy. Thanks for having me again, and have a good evening.
Thanks, Peter.
Yep, see you later.
All right, so now we're gonna just talk a little bit about our plans for 2023 and a couple other things, and then we're gonna do the really fun part of this, which is some shout outs to volunteers who really went above and beyond this year. So as we discussed before, oh, let me get this in sorry, slideshow mode there. I talked a little bit before about how we released the Pika Patrol app this fall, and we're really excited to get you guys out across the whole state or just anywhere that you're recreating next summer to record pika observations. You know, we're doing really intensive surveys across our study areas, but we don't know that much about what's going on with pikas across the rest of the state. So we're excited about the data we're going to be able to collect with that app. We're also just started a volunteer Facebook group, and we're hoping that you guys will all be able to use that to connect and find hiking partners and share your photos and just kind of interact and, you know, potentially not have to find a hiking partner by emailing us and then having us look through all our emails to see if there's anybody else who's emailed us. So we think that's going to be a great way for you guys all to connect. You know, I don't think either Alex or I really love Facebook, but it seems to be the best setup for setting up groups like that. And so we're going to have you guys try it out this year, and we'll see how it works. We're also planning to do a few more survey 1, 2, 3 improvements. There's a few things that still don't work great and are kind of annoying for volunteers that we are planning to fix. And, you know, both Denver Zoo and Rocky Mountain Wild had sort of particularly busy years this year. So we also didn't finish the survey 1, 2, 3 app that you could have on your phone to do your surveys if you wanted to record the data at your sites right there on your phone. So we're going to be working on that over the winter. we're also going to be doing extirpation surveys, like I mentioned. So going to a lot of the lower elevation sites where we only find old pika sign and surveying a bigger area to find out if pikas are still present at those sites or if they've been lost from those sites. We're going to be doing a bunch of analysis and cleanup of data. And we're also hoping to work with a bunch of other folks across the state to put together a Colorado Pika Atlas. This is a little bit of a longer term project, but we'd like to have a central online database where land managers and researchers can go to find all the data that we have about pika in Colorado, figure out where they were in the past, where they are now, that kind of thing. And then Chris Ray's graduate student, Irie Peralta, is going to be using all of your data in her PhD research. I think it's going to be really interesting. She's going to be doing some occupancy modeling to try to look at things like, the Pikas in Peril program made some predictions about how pikas might decline in the park over time, and she's going to look at whether that's starting to happen yet. So I think her work's going to be really interesting, and we're excited that she's going to be using our data. And then just like always, we really love to hear any ideas you guys have for improving the project. This project wouldn't be anywhere near where it is without ideas of past volunteers. So we really, we read all your surveys, we read all of your comments on our end of season survey. And so definitely let us know if you have ideas about things that could be improved. I also wanted to talk really briefly about the Colorado Carbon Offset Partnership. I know that Peter's presentation may have made some of you feel a little bit sad. It's kind of sad to know that pikas may be retracting upslope in response to climate change. And, one thing that we feel pretty confident about from the past research that has been done is that if we can slow down climate change, if the climate changes more slowly, then we'll be less likely to lose pikas across Colorado. And there's a couple ways we can do that. We can reduce our carbon footprints. But another way to do it that I think is really exciting and is to sequester carbon in carbon sinks. And our grasslands here in Colorado are actually really good carbon sinks. So they have really deep roots that hold on to a lot of carbon and kind of sequester it in the ground. And then they're also pretty stable carbon sinks, even more so than forests, because when grasslands burn, it just burns the grass, it doesn't burn the roots, and then the grass comes back. So that carbon kind of stays in the ground. And so we have set up a new partnership with an organization called Southern Plains Land Trust. And if you donate to that partnership, Southern Plains Land Trust will use the donation to buy prairie that would otherwise be converted to subdivisions or be plowed and lose its ability to be a carbon sink. And they will permanently protect that prairie with conservation easements. And it's also permanently protected as a wildlife refuge, which is just kind of a nice bonus in addition to the putting carbon in a carbon sink. And then 20% of your donation will go to the Colorado Pika Project. And we are going to put that money into a fund that we're going to keep so that we can help pikas cope with climate change in the future when we start to get more and more results from our research and the research that other researchers are doing here in Colorado, and figure out things like, maybe there are places on the landscape where pikas are going to be more resilient to climate change and really likely to last into the future, potentially at higher elevations. And, we could think about in those places how to protect them from other threats like rabbit hemorrhagic disease virus or lots of recreationists trampling all the vegetation or things like that. So we're pretty excited about this partnership. The other thing that's exciting about it is that purchasing prairie in the Eastern Plains of Colorado is a really easy thing to do because the land is so inexpensive. So for a donation of $270, you could offset an entire year of your carbon emissions. And then you could preserve a half an acre of grasslands, because the grasslands down there are about $400 an acre. And you can contribute $54 to help pikas cope with climate change. So we're excited about that partnership. If you want to donate, you can go to our website and click on Take Climate Action, and it will take you to a page that explains more about this partnership and has a link to donate. All right, now the fun part. I'm going to hand it off to Alex so that he can do some shout outs and thank folks for amazing things they did this summer.
I'm excited to talk. I have a bit of a cough, so I apologize if I have to mute myself for moments. But this is by far my favorite part of this celebration because it's when, I mean, it's the whole reason that we're actually here. We're really here to say thank you to all of you for being part of the Colorado Pika Project for another year. As Megan said, this project would not exist without you. We could not, we could not survey nearly the extent or the depth of data that we do without folks like you, without the over 200 people who participated this year. It's awesome. So you all deserve a round of applause. Thank you so much for your time this year. As a show of our gratitude beyond just our words, we have volunteer goodies that are that we'd love to offer to anyone who went out and collected data this year. In addition to our fun hats, which we had made last year, we also now have these new pins, which you can see on the screen. The little pin that says 2022 Pika Patroller. I think I have mine right here. They're pretty cute. And we're hoping that we'll have a unique pin every single year. So if you participate year after year, you'll have a whole set of pin to remember each year of being part of the Pika Project. And we also have stickers. And obviously this is a virtual celebration, so we can't just hand you a hat, which makes us sad. We're really happy to see folks at the in-person event, but we get that a lot of folks cannot make it all the way to the Front Range for that, and we're happy to have folks here online as well. But if you'd like a hat or a pin or stickers, please fill out the volunteer survey that we sent to everyone, and there are questions at the end of that asking about your mailing address or the best way for us to get those items to you. All right, so having thanked everyone, I also want to take some time to give specific shout outs to people who really just went above and beyond this year. Folks who did like large numbers of surveys or really had a lot of attention to detail or just went above and beyond for the Pika Project. Obviously, everyone deserves credit for putting any amount of time into this, and the vast majority of people who attend the trainings really don't actually get out to volunteer. So any number of surveys is worth recognition, but I want to call out the folks who did the most surveys in each project. So for Rocky Mountain National Park, that's Jill Jackowicz, who went to 5 different sites, which are some pretty great ones, including some sites up in the Never Summers, which are really hard to get to, like Green Knoll or Opposition. Thank you, Jill, for your time this year. You've been an awesome volunteer. I hope you come back next year. Then in White River National Forest, Andrea Tupi went out to 4 sites, including some really beautiful ones and some really terrible ones like Granite 011, as Megan knows well, is the trail is mostly down logs. So thanks, Andrea, for sticking with it and making it out to sites like that. We really rely on volunteers going to hard to reach sites because those are the ones that really take a lot of our time, and we appreciate folks who can make it to those. Then in the Front Range, Mary Rash did 7 surveys, which is crazy. And on top of that, she also had the most miles hiked of anyone in the project, which is 36 miles. Absolutely ridiculous. Mary was at the in-person celebration, so we got to thank her in person, and she deserves so much credit. She's been with the project for a really long time and is just, a model among volunteers. All right. As well, I want to give an honorable mention to a handful of other folks who also did a large number of surveys. That includes Caleb Hazlett and Tatiana Klein, who made it out to also 5 surveys, but divided between Rocky and White River, and so they fall through the cracks. But I also want to mention that Caleb and Tatiana actually made an attempt at Onahu. I forget the numbers for it, but our Onahu site in Rocky Mountain National Park, which is one of our extreme sites. It's a really rough one, and they made an attempt at it, tried to get a new hobo logger out there, but we're not able to make it up there. But they deserve a lot of credit for even attempting one of those really extreme sites. They're beautiful, but they are not easy to make it to. Then Cora Marama, 4 surveys between Rocky and White River. Steve Rash, Mary's partner, 5 surveys. Thank you, Steve. The Furmeister family, who made it up to a handful of sites in Rocky Mountain National Park. And also let us know that one of our hobo loggers had mysteriously disappeared from the Iceberg High site. It happens. The pikas are not kind to them sometimes. And then David Sager, here with his beautiful umbrella in a rainstorm, 4 surveys up in the Front Range. Thanks to everyone who did all these surveys. As well, I want to call out Jennifer and Sophie Zadalis. They reached out to me at the start of the summer to let me know that our site description, our resources were totally off for the Coon Hill site up by the Eisenhower Tunnel. Like you can see in the photos here, we had the site marked as where the navy blue pin is. But if you can see the little sun symbol that they've drawn on here, that's where it actually was, over 100 meters off. And so they took the time to search that whole area, use the photos we provided to actually figure out where the right location is. And that, makes a big difference, because if we aren't collecting data at the right location, the exact right spot for the White River and Rocky Mountain National Park sites, we really can't use that data. So thanks, Jennifer and Sophie, the awesome mother-daughter duo, for correcting this error. Then Nancy Weaven and once again Mary Rash deserve credit for the outstanding feedback they've already given us on the Pika Patrol app. As Megan said, with this new app, we know that there is a good few bugs with it, and we really figure out those problems and can solve them only if people reach out to us and let us know how they encounter the problem, what's going wrong for them. And Nancy Weedman and Mary have sent us some really detailed information about that. So thanks you two for helping us to make the Pika Patrol app better. Then Lauren and Joe Simpson, as they've both gone above and beyond, outside of the traditional framework of volunteering on this project. Lauren has been putting in a lot of work to help us set up the Pika Patrollers Facebook group, which I'm really excited about. We announced it just a few days ago, and we already have over 50 people who've joined the group. I do not like Facebook, but I'm really excited to have a way to connect and stay in touch with Pika Project volunteers and give people a venue to share photos or ask questions about the protocol that can be answered by other volunteers and not just by Megan or me a week and a half after the email was sent. So thank you, Lauren, for spending time on that. And then Joe is helping us to overhaul the site selection process, creating some new tools to make it easier to say all right, I only want to visit sites that are less than a 3-mile hike and are close to Silverthorne or wherever. Which sites are that? Joe's creating a system to help narrow that down in a really fluid, easy way, and hopefully make it a lot easier for folks to figure out what's the best spot for them to go survey for pikas. All right, and then this is just a little, fun observation that I noticed this year. It's fun and it's also a little bit concerning, which was Kathy and Jacob Traugott up on a camping trip in Rocky Mountain National Park where they were surveying for pikas. They were up at the Dutch High site, and then after descending from it and going to a nearby site, Dutch Low, they realized that there was a rock slide going on up at the first site that they went to. not ideal, slightly concerning. I think that I really want to mention this because it's a reminder that it is oftentimes that talus is much more slippery and more likely to slide after a rainstorm, which was the scenario here, and that you should really be cautious surveying for pika sites after rain or if there's rain on the forecast, especially at a site where it says in the resources we provide in the fact sheet in the site description that the talus is really unstable. So please keep that in mind. Safety is always the number one thing, as we say in the trainings. All right. And then you might recall, this is my last slide. You might recall that back in September, I sent a maybe slightly desperate email saying that there were a number of sites that we hadn't had any visits to and asking folks to try and make it out to those spots. And we had a really awesome amount of enthusiasm for reaching some of those hard to reach, difficult sites. So thank you to everyone who's here on this page who visited one of those spots that hadn't had any visits by the end of the year. And I'll also say that in addition to hats and pins and fun things like that, the folks who I've mentioned here are going to be receiving some special cards from our Pikas and Prairies photo exhibit, and we'll be reaching out to them about that. They're really cute. They have nice photos from Kristi Odom of pikas and prairie dogs and other fun wildlife on them. So above all, to wrap up, thank you all so much for your contribution this year, not just the folks who I called out by name today. All right, so that is what we have for you all tonight. This, as we said, has been recorded and we'll be putting it up on YouTube and emailing it to the whole crew possibly next week. So if you want to rewatch Peter's presentation or anything like that, you'll be able to. But for right now, thank you all so much for joining us tonight. And Megan and I are happy to stick around and answer any questions you might have. Feel free to ask them in the chat or unmute yourself if you'd like. But thank you for another awesome year of this project. We're always so excited to work with you, and we're so grateful for the time you give to us.